To overcome some of the most common challenges with the use of polyclonal antibodies, scientists have developed a new format of antibodies, which are called recombinant antibodies. In that situation, the antibody that has already been selected through the monoclonal production is then isolated on its particular variable portion. That variable portion, if you guys remember, is exactly what determines the specificity of an antibody for a particular antigen. So what we can do is we're going to identify that portion, we're going to excise it, and we're going to clone it into a plasmid. That plasmid is going to produce not only the variable portion of that antigen, but will also produce other fragments of your antibody of interest. That could encompass a whole antibody with Fc and Fab regions, or different smaller parts of an antibody, depending on what your goal for the use of that antibody is. That plasmid is then inserted into a bacteriophage, which allows for massive production of that antibody of interest. We can also create libraries of bacteriophages so that we can more quickly select a recombinant antibody of interest. Once that antibody is produced by your bacteriophage, it can be purified. As it is to be expected, there are going to be advantages and disadvantages to the production and use of recombinant antibodies. Some of the advantages and disadvantages of using recombinant antibodies are, these antibodies are going to be extremely high specific and pure. They are also easy and fast to produce once the bacteriophage library is concluded. They can be adjusted to be produced or expressed into different background plasmids, which means they can be of different isotypes and subclasses. Also, once the bacteriophage library is prepped, the production is animal-free. Now, some of the disadvantages of using recombinant antibodies are that the initial development is very costly and convoluted, and unfortunately at this point there's only very few options that are commercially available.